Hello everyone and welcome. Thank you for taking the time to watch this presentation and demo. We're excited to show you some new capabilities which will make it easier for you to build and deploy serverless applications at scale with Prisma and MongoDB. My name is Kevin Jernigan and I'm a product manager at MongoDB on the MongoDB Atlas Serverless team. Prior to joining MongoDB in February of this year, I'd spent most of my career working on relational databases. I worked for Oracle twice and most recently for Amazon Web Services, managing the launch and growth of Aurora Postgres. I joined MongoDB because I'm excited about how much easier it is to build applications with MongoDB as compared to relational databases, and I'm double excited about MongoDB Serverless and the whole serverless application paradigm. With me is Matt Mueller, a software engineer at Prisma. He will give a demo of Prisma Data Proxy working with MongoDB Atlas Serverless. Okay, let's get started. We've already done introductions, so I'm going to dive into an overview of MongoDB Atlas and Atlas Serverless, and then talk about how to build and use serverless functions and applications with MongoDB Atlas. I'll then get into a couple of new capabilities that make it even easier to use serverless functions and applications with MongoDB Atlas, and Matt will give us a demo. Let's first talk about MongoDB Atlas, starting with a brief description of MongoDB itself. Most of you are probably familiar with MongoDB. As a database, MongoDB helps increase developer productivity with our document data model, rather than forcing you to think in terms of rows and columns and fixed schema tables, or wrestle with ORMs and DBAs and other points of friction in traditional application development. Atlas is our managed MongoDB service, delivered in all three major cloud providers. The primary goal of Atlas is to automate the boring, repetitive manual steps someone needs to take on when building and managing databases for applications. Atlas goes beyond automating to provide elasticity, hardening against common failures, and recommendations for improving performance and resource utilization. And Atlas itself is part of the MongoDB Cloud Platform, which includes things like integrated full-text search with Atlas Search, automatic user-controlled data archival with Online Archive, and mobile and edge-to-cloud data synchronization with Atlas Realm. MongoDB launched Atlas a little more than 5 years ago, and in that time, customer usage has grown 340% year over year, with more than 1.5 million database clusters deployed on MongoDB Atlas as of today. This has led Forrester to name MongoDB as a leader in the database as a service market, putting us in the same category as Amazon, Microsoft, Oracle, and Google. The key difference is that we're in the leader category because of one product, MongoDB Atlas, whereas the other leaders are there because of multiple databases. So with that background on MongoDB and MongoDB Atlas, let's talk about serverless. To set the stage, let's start with some common truths that I'm sure we can all agree with. Nobody likes sizing infrastructure. Sizing is a hard problem, with ambiguous inputs at best, and two pain points are often cited when we talk with customers about sizing: resource coupling and deployment friction. Deciding how much compute or memory or storage you need requires predicting future activity and translating your application's requirements into arbitrary units. Databases traditionally couple compute and storage resources together, which means that in order to get more of one, you have to get a bigger machine, even if you don't need more of the other resource. Therefore, you always have to get the machine that can meet the requirements of the resource you need the most of. This often leads to deployment friction. Teams don't like to have to go through a complex sizing exercise before every project just to select and configure the database. And the consequences of incorrect sizing infrastructure are plenty. If customers aren't confident in their sizing, they'll feel the need to constantly monitor their resource consumption and make sure you have sufficient capacity and otherwise adjust it. Or even if you size it correctly initially, your application may experience a change in workload patterns that requires you to go back and adjust your resources accordingly. If you have incorrectly sized and under-provisioned, your applications may become slow or even choke and be unresponsive if they hit a bottleneck. And if you over-provision, you'll have to pay for unused capacity, which quickly can become expensive. We can help solve some of these pains today. MongoDB Atlas offers auto-scaling on both compute and storage resources, which reduces the need for customers to manually scale up and down their dedicated clusters. We also offer professional advice on sizing clusters for various workloads, which can be delivered by SA or via consulting engagements. These solutions reduce some of the pain of sizing infrastructure, but not all of them. Let's revisit the 3 negative consequences again. Autoscaling helps reduce management overhead, so that's generally good. However, when it comes to performance consequences, autoscaling can't prevent all of them from happening. We invested a lot in building our autoscaling capabilities to accommodate the majority of workloads, but they don't always respond fast enough to all scaling scenarios. And when it comes to cost, autoscaling can save customers some money, but likely not a lot, since you're still tied to cluster tiers which have standard hourly rates. Even if your cluster is scaled down for some amount of time, you're still paying for all the resources that come with it, whether or not you're using all of them. So what does that mean? It means that today we can help relieve some of the pain of sizing infrastructure, but we may not be able to meet all of our customers' required capabilities. Specifically, there are 3 types of workloads that we can't really serve well today. If you have really imbalanced compute and storage workloads, our cluster tiering model may not be that attractive. While we do offer some elasticity when it comes to storage capacity on our dedicated clusters, it may not be enough for all workloads. For example, if you need the compute power of an M200, but the storage capacity of an M10, you still have to pay for an M200. Another scenario is really spiky workloads. Our autoscaling mechanisms aren't built to handle large and sudden changes in workload requirements, so you may still experience performance consequences in your applications. And finally, not all workloads are constantly running. You may have a microservices architecture that runs a job once a day for 5 minutes, or once a month for 3 hours. These types of infrequent and sparse workloads aren't cost-effective to run on Atlas because there's so much idle time, and therefore you're paying for a lot of unused capacity. So why do developers care about serverless? Serverless delivers on 2 main goals. The first is elastic scaling, the ability to automatically scale up and down based on workload, including the ability to scale down to 0 resources when there's no workload. And then there's consumption-based pricing, which is a pricing model that only charges for resources used to service your workloads. The serverless application model results in an abstraction that frees developers from needing to think about servers, hence serverless. This model has the following benefits. You don't need to think about scaling up to meet increasing workloads. You don't need to worry about paying for resources you're not using. So serverless computing is a model that dynamically uses only what it needs and only charges for what it uses. Now, AWS Lambda is often credited with starting the serverless movement, and their cloud peers have launched similar capabilities, including Google Cloud Functions and Azure Functions. Let's dive into serverless instances on MongoDB Atlas. Serverless instances are now available to the public in preview in Atlas. We launched the preview back in July. This is a new serverless database offering in the market and has 3 main benefits. First is seamless deployment and scaling. You no longer have to determine what cluster tier or storage you need for your database, neither at deployment nor on an ongoing basis. With serverless instances, you simply create a cloud database and it will automatically and dynamically scale to meet the demands of your workload. Second is reliable backend foundation. Serverless instances are built on top of the same foundations as dedicated clusters, and therefore offer many of the same built-in best practices you've come to expect, including continuous uptime, end-to-end security, backups, metrics, and more. It will always run the latest MongoDB version, starting with 5.0, and then following the rapid release schedule. And the third is intuitive operations-based pricing. In the serverless model, you only pay for what you use. In the case of MongoDB Atlas Serverless instances, we will charge you for reads, writes, and storage. Now let's go through each of these in a bit more detail. Serverless instances come with the same best-in-class operations and features of a fully managed database, including end-to-end security, continuous uptime, backups, automated upgrades, metrics and alerts, and index suggestions. Ideally, developers rarely have to monitor their database or restore their data, but in case they do, we offer tools to help them troubleshoot and get back on track. Even though it's a preview, the serverless instances still include all these capabilities. All of this gets us closer to meeting those previously tricky required capabilities, but since it's just the first release, we still have some work to do. So let's talk about the areas we want to focus on over the next few years of MongoDB Atlas Serverless. The vision, of course, is to be able to use serverless to meet all of the required capabilities that you have for your workloads. And we are working on multiple projects to further separate compute and storage in serverless, as well as projects to improve scalability for spiky workloads both up and down. And we're watching very closely as customers bring a variety of workloads into the serverless preview to learn how to improve our pricing model. So what is our vision for Atlas Serverless? Well, we believe that the serverless model will become the default way for you to use databases in the cloud. This is because serverless realizes the promise of the cloud by abstracting and automating more and more of the low-level infrastructure configurations that developers and engineering teams don't want to have to learn or maintain. Now, it may take a while for the shift to happen in the industry. Many companies are still early in the journey to the cloud, and the idea of a serverless microservices architecture may be years away for them. Some companies may also never come around to adopting the cloud for one reason or another. However, the shift is already happening. The global serverless architecture market size is projected to grow from around $7.6 billion US dollars in 2020 to around $21 billion by 2025. Now that we've talked about MongoDB, MongoDB Atlas, and MongoDB Atlas Serverless, let's talk about how you can build serverless functions and applications using MongoDB Atlas. Before today, if you wanted to build a serverless app using AWS Lambda or Google Cloud Functions or Azure Functions and connect that app to an Atlas managed database, you had to write code to use one of the many drivers supported by MongoDB to connect directly to the database over TCP/IP. While this is relatively easy to do, it requires you to implement and maintain extra code in your serverless apps and can add significant latency to your database queries because a new connection will be created and then destroyed for each call you make to the database. Instead of making a traditional database connection, you would ideally be able to use a RESTful HTTP call to access the database. This would be much less coding work and much lower latency, but this wasn't possible with Atlas MongoDB. Until today, we're launching the MongoDB Data API, which provides HTTP access to do standard CRUD, create, read, update, delete, CRUD operations on a MongoDB Atlas managed database. This will greatly simplify the process of building serverless applications that need to access data in MongoDB databases. The MongoDB Data API is in preview, and we plan to support both MongoDB Atlas dedicated and serverless databases. Now let's get to the best part of this whole presentation, Prisma Data Proxy together with MongoDB Atlas. What if you're not only building a serverless application, but you're building one that needs higher scale, needs to be deployed on the edges of the cloud using something like Cloudflare workers? You'd like to connect the Cloudflare workers to your MongoDB Atlas database in the cloud, but Cloudflare workers can't use TCP. They only use HTTP. Now, you might think to use the MongoDB Data API we just announced, but sometimes the scale of traffic may be higher than can be easily supported. Because while the Data API doesn't require you to create and tear down a database connection for each database call, there's still some amount of connection overhead for each HTTP call. With the Prisma Data Proxy, you can now point a large number of Cloudflare workers at the proxy and use the proxy to manage a smaller and stable number of connections to a MongoDB Atlas database. This greatly reduces the connection overhead on the database, simplifies the application development process, and reduces latency for database requests. The Prisma Data Proxy is now available in preview for both MongoDB Atlas dedicated and Atlas serverless databases. To see all of this in action, Matt Mueller is going to show us a demo. Take it away, Matt.
Thanks, Kevin. Now I want to show you how to create a Prisma project connected to MongoDB Atlas deployed to Cloudflare workers. Let's jump into VS Code.
All right, so today we're going to be creating a simple logger that takes requests from the Cloudflare worker and logs them to a MongoDB database. Now I'm going to be starting from scratch because I want to show you how easy it is to actually get something up and running. It may move a little bit fast, but I'll be posting a link to the guide that you can kind of follow along on your own time. Okay, so to get started, we are going to need a MongoDB Atlas database. They are free to set up. You'll need Git and a Cloudflare Worker account, which is also free. Okay, so I'm going to initialize npm, and then I'm going to install some dependencies. And we're going to be installing Prisma, TypeScript, some types for Cloudflare Workers, Webpack, and TS Loader for compiling TypeScript to JavaScript. The next thing we're going to do is actually initialize Wrangler. And Wrangler is the official CLI for Cloudflare Workers. It manages the deploying, developing on it, and everything else. Next, I'll use npm Wrangler login to actually log in with a Cloudflare account. I've already done this, so you would normally say yes, but I'm going to say no in this case. The next thing we're going to do is set up our TS config, so npx tsc init to initialize our TypeScript configuration. It creates this boilerplate TypeScript file. I'm going to go ahead and replace this with a smaller one. There's not anything crazy here. We're targeting ES Next, and we've got this Cloudflare Worker types global type definition here that I'll explain a little bit more in a bit. Okay, so one of the cool things about Wrangler is it actually integrates with Webpack, and so we can actually supply our own Webpack config, and it will run this before deploying to Cloudflare Workers. So we've got this Webpack config. It's pretty basic boilerplate. You've got this entry TS file, which will define that'll be where our worker is. It will output to worker.js. We're targeting web worker because Cloudflare Worker environments are based on V8, and if it doesn't have the Node.js runtime or like the DOM or anything, so this is kind of the closest target for that. We've got some aliasing here to make sure that Prisma resolves to a Cloudflare Worker type build. We're going to make sure that DevTool is none because Wrangler doesn't like evals, which this produces when it's on. And then the last thing we're going to do is compile a TypeScript file to JavaScript before deploying to the Cloudflare Worker. Okay, and now we need to tell Wrangler where it can find that Webpack config. And so I'll just add this line here, Webpack config, and point to that file we just created. And now we're actually ready to initialize Prisma. So I'll do npx Prisma init, and that will create a Prisma directory and a .env file. I'm going to go ahead and copy and paste in our schema.prisma. And this is a very simple schema. It's got a log for which you can log levels, log a message, and log any meta information. And there's two preview features here that we've enabled. We've enabled the MongoDB preview feature for talking to MongoDB databases, and the data proxy feature for deploying a data proxy ready Prisma client. Okay, with all of that, we are actually ready to create a GitHub repo, and this will serve as a place to store our code for the Prisma data platform to be able to read. So I'll just go ahead and say Prisma MongoDB Cloudflare here, make it private, and I'll go ahead and create that repository. Okay, and then I will run the necessary commands to push up to that repo. Need to adjust the username here. Add all the files, make the initial commit, and push up to origin main. So if all is well here, we've got the new files here. Okay, and now we're ready to actually log into the Prisma data platform and connect our GitHub repo and our code to a new project there. So I'm going to go ahead and go over to create project. I'm going to name this one Prisma MongoDB Cloudflare. And I'll go ahead and import that repository we just created. Prisma MongoDB Cloudflare, here it is. And I'll use the main branch. Always takes a little bit for a second, but what you can see, it's figured it out up here. Okay, and then I'm going to use my own database and provide the MongoDB connection string that you can find actually right in here. And we're also going to create a data proxy, which will allow us to not run into connection limiting issues. Okay, we've created the project. Now I'm going to take this connection string and actually bring it into my project now. So this is actually a URL to the data proxy, which then connects to your MongoDB database, and it manages the connections and talking over HTTP. So now that we've got that, we are going to go ahead and generate a Prisma client that can talk to the data proxy. And so the way you do that is you define an environment variable here that says the engine type is talking to the data proxy instead of talking to the query engine binary. That is the default. So we'll do data proxy npx prisma generate. We'll run this, and this will generate a Prisma client based on our schema.prisma file that we defined here. So now we are actually ready to define our worker. So I'm going to go ahead and create a source index.ts file, and I'm going to go ahead and copy and paste our Cloudflare worker. And what this does is upon fetch, it will run this function here. And this function just creates a info log with the request method and request URL, logging any headers. And then it responds with what the request method was. It's a very simple function. So we've got a couple squiggly lines here. There's some interdependency with the tsconfig.json, which uses this, and what the types are in here. And so you just need to save the tsconfig to refresh everything. All right, let's see if this is now working locally for us. So I'm going to go ahead and run npx wrangler dev, which sets up a Cloudflare worker-like environment locally. Okay, let's see if this is actually working as expected. So I go to localhost here, and we can see request method get, which is awesome. I'll run this a few times, and it looks like it's working. So now that we've got that, we're actually ready to publish our Cloudflare worker to Cloudflare workers. So I'll run npx wrangler publish to do so. And we're going to be given this URL here that I can go ahead and open. And you'll see actually that it works. Everything works as expected. So I'm creating a couple of requests here to see everything work. And now let's just verify that this is actually connecting through the data proxy and talking to our MongoDB database by going to the Prisma data platform and opening up the data browser here, which allows you to read from the database that you configured. And you'll see that we've got this log collection here. And you'll actually see that we've got all these messages that we've created. And so one of the interesting things about logging requests is you get to see how the browser works, which is kind of cool. So you'll see that the favicon is actually requested first, and then the actual URL we requested. So that's pretty sweet. What we've done was we set up from scratch a way to log your requests to a MongoDB database through the data proxy. And that's all I've got for you today. I hope that was informative. And if you have any questions, please reach out to us. Now, back to you, Kevin.
Thanks for the demo, Matt. That was really cool. So we launched MongoDB Atlas Serverless instances in preview in July, and we're working hard to get to GA in the next year. Working with customers in the preview, we're continuing to improve on key areas for serverless: migration to and from serverless, seamless scaling for all types of workloads, and intuitive and affordable pricing. We believe that the combination of MongoDB Atlas Serverless and Prisma Data Proxy will greatly simplify the process of building and deploying serverless applications in the cloud, especially for workloads that need to scale to high connection counts. The Atlas Data API will be ideal for developers who don't use Prisma and for applications that need a moderate number of connections. We're looking forward to working with Prisma to continue to improve support for developers building applications in the cloud. And please reach out to me or Matt with any questions. And thank you for taking the time to watch our presentation and demo today.